Swayam Prabha. Digital India. Educated India.
Now I will show you another one. These cases could be a lot more complicated, but for simplicity I will use something similar to what I had earlier. Let us say you are given this whole circuit and you are asked to find the Thevenin equivalent between the terminals A, B. That is, we need to find the Thevenin voltage and the Thevenin resistance between A and B, and that also can be done in terms of the 2-port parameters. Okay. So, in this case let me assume that the 2-port is described by Z parameters instead of Y parameters. Okay. So, what will I have? I will have this V1, I1, V2, I2, and I know that V1 is Z11 I1 plus Z12 I2, V2 is Z21 I1 plus Z22 I2. Okay. Now, I need to find the Thevenin voltage. That is, I do not connect anything between A and B, I have an open circuit and find V2. Okay. Now, in this particular circuit, if we have an open circuit between A and B, I2 will be 0. Now, this is not necessarily always the case. Okay. This is the case in this particular example. Okay. So, for VTH calculation, in this circuit I2 happens to be 0. That may not always be the case. For instance, we could have some load connected here, in which case I2 will not be 0. Okay. So, V2 will be simply Z21 times I1, and that is VTH, right, the open circuit voltage that appears here. Now, what is I1? That we can find out from this side. We know that Vs minus V1 divided by Rs is I1. Okay. And also we know that V1 is Z11 I1 because I2 is 0. Okay. So, putting these two things together, we will get I1 to be okay, Vs by Rs times 1 by 1 plus Z11 by Rs. Okay. So, this is what comes out of the calculation, and V2 will be simply Z21 times this value. So, it is Vs times Z21 divided by Rs plus Z11. Okay. So, in this particular case it happens to be Vs times Z21 by Rs plus Z11. Now, we also have to find the Thevenin resistance. For that, we set the independent source Vs to 0, we have Rs and we have to find the resistance looking back into this one. Okay. That is, for instance, this is V2 and this is I2. We can think of injecting either a voltage or a current source. This has nothing to do with what parameter set we choose, right. This is described by Z parameters, but I could apply a voltage source on this side. Okay. It is only for measuring the parameters that we apply a current source in case of Z parameters. So, let us say I do apply a current source, I test. Clearly, you see that I2 is exactly equal to I test. So, what I need to find is the ratio V2 by I2. That is the resistance looking back between the terminals A and B. Okay. I also have this V1 and I1 over there. Now, again we have V1 is Z11 I1 plus Z12 I2 and V2 is Z21 I1 plus Z22 I2. Now, because we have this resistance here, we have a relationship enforced between V1 and I1 by Ohm's law. So, V1 is minus I1 times Rs. This is because of the direction of variables chosen. I1 is flowing out this way, whereas V1 is defined with this polarity. Okay. Remember, we need to find V2 by I2. That means we have to eliminate V1 and I1 from these two equations. Okay. So, if I substitute this, I will get minus I1 Rs is Z11 I1 plus Z12 I2, and from this I get I1 to be minus Z12 divided by Z11 plus Rs times I2. Okay. And I will substitute it in the other equation. I will get V2 to be Z21 times I1, which is minus Z21 Z12 by Z11 plus Rs times I2 plus Z22 times I2. And the Thevenin resistance, which is nothing but V2 by I2. I2 is the same as I test, and V2 is the voltage developed wherever you apply I test. This will come out to be Z22 minus Z21 Z12 divided by Z11 plus Rs. Okay. So, that is what we are going to have. So, this whole thing, and it could even be a lot more complicated than this, is equivalent to a Thevenin source in series with a Thevenin resistance, where the Thevenin voltage source is given by Vs times Z21 by Rs plus Z11. You see that it is dependent on this network as well as the voltage source and resistance connected to it, and RTH is Z22 minus Z21 Z12 divided by Z11 plus Rs. Okay. So, you can have a 2-port and some circuit using the 2-port, and the whole thing can be represented as by its Thevenin equivalent circuit. So, there are many more calculations you can do. The principle is always the same. You use the 2-port parameters and the relationship implied by them. That is, you have the voltages and currents of the 2-port, and you have some relationships between the voltages and currents, and also the circuitry that you connect outside of the 2-port will impose some relationship between some of these variables. By solving for all of these equations and eliminating some variables, you can find whatever you want. Okay.